Ben, can you hear me? All right.
All right, so bear with us a little bit. Our next presenter, James Whitlock, is presenting remotely, so we'll get that dialed up here. I'll give you a little brief intro for James. James is a mining inspection enforcement coordinator for the BLM in Anchorage, Alaska. He's been the BLM Alaska Mining Inspection and Enforcement Coordinator since 2017. Prior to that, he spent 10 years as a BLM Mining Compliance Inspector for the southern half of Alaska. James received his bachelor's degree in environmental science from Alaska Pacific University, where he was introduced to the challenges of ecological restoration in Arctic and subarctic environments. James retired from the U.S. Air Force, where he spent most of his career in civil engineering in support of large construction activities.
All right. Hopefully you can hear me, Ben. All right. Let's see if we can. Hopefully everyone can hear me, and can see my slides. Okay, go ahead. Ben says. All right. Thanks everyone. Appreciate you entertaining me here virtually. It just didn't work out to travel down there, but we'll make this as exciting as we can, and we'll get going here. So BLM Alaska, we have we're a placer mining rich state. Lots of placer mining since the earliest days. The BLM manages over 70 million acres of public land up here. And within those mining claims, we have within our active mining claims, we have over 315 miles of streams. And we have about over 1,000 miles of streams that are either in closed mining claims or have seen some level of mining activity since mining really started here. And within that, we have a large majority that are still post-regulation impacted streams. So we've managed a variety of placer mines throughout the state. We have modern day operations, we have historic operations, and then on top of that, you have the state of Alaska itself. The state manages a very large placer program, and we have a interconnected system of operations that kind of stack on each other within one drainage. So it's often an interesting situation and challenging. But Alaska's resources are abundant. We're a very wet state, and we have placer reclamation obligations often cover streams, rivers, wetlands, and various other components. All right. So placer mining often requires disturbance in or near the stream. That's just the nature of placer mining. And even if you're up on a bench deposit, you're still going to be having some level of impact potentially on the stream in the form of stormwater controls, settling ponds, or whatever. And it's not uncommon for operations to divert their streams to have to be able to access their pay. So depending on the valley size, the type of mining you're doing, stream dimensions, how big your floodplain bench is, you may end up having to move the stream back and forth within the valley in order to facilitate that mining activity. Preferentially, operations would like to minimize the number of times they have to touch the stream and move it. And so permanent relocation is the ideal method, where you essentially just move the stream to a point somewhere in the valley that you don't have to worry about removing it later on and doing future reclamation. The BLM really encourages that because we can perform essentially the reclamation up front, and while the operations are active, they can maintain, do maintenance on the reclamation as needed. But overall, the key thing is that reclamation is required of streams, and that's within our regulations. We have a requirement for reclamation of the mine site. And in addition to that, Alaska is obviously a very rich state in sport fisheries, but also anadromous fisheries. And so rehabilitation of fish and wildlife habitats important component. And also we have nationwide policy. And it says, for placer mines, reclamation should include a stable channel form with adequate vegetation to reduce erosion, dissipate stream energy, and promote the recovery of in-stream habitat. And so with all of this, the BLM kind of wanted to look into what has happened in the past and how can we move forward to work with the mining community in collaborative effort to facilitate more effective reclamation. So past approaches, this has been pretty common within the industry statewide, and possibly you could extend this to nationwide, which, stream reclamation was you put a pilot channel in place and you assume that natural recovery processes would take over and eventually stabilize the channel and lead to habitat recovery. This photo here is 1 year post reclamation. The second year, you had a massive movement event. This isn't a flood. This was just a standard breakup. This was a normal, actually kind of dry period. But you can see the volume of material removed. There's a person standing there. So that bank is 7 to 8 feet tall. That happened in one breakup season, the amount of material moved off of there. And obviously this creates a condition where you have the inability to promote vegetation. Obviously in the stream diversity within its bed form becomes very homogeneous. You get a lot of mid-channel bars and head cutting. So there's a lot of problems that can come from just having this kind of piloted panel plan approach. And then even years later, 15, 20 years later, streams still struggle to recover. And here in this photo, you can see that it's a homogeneous, essentially just one giant riffle. There is no stable, long-term, healthy vegetation due to the consistent erosion and the fact that most of Alaska has a very short growing season, and the conditions aren't favorable to really kickstart a fast stream channel when you don't set the conditions off right early. So why is success so elusive? Well, it's been a question here in Alaska and the Canadian Yukon for a long time, especially post 1980. Over thousands of pages have been written and studied to address placer stream reclamation, and lots of people have put a lot of work behind it. But unfortunately, translating written guidance to something on the ground isn't as straightforward as one would seem. There was just a significant lack of understanding what was going on, a data gap. But then also, Alaska just doesn't have the depth of consultants and experts in this field that are able to support small-scale placer miners. And so these kind of limited functions really contribute to the stream channel issues and long-term reclamation success. In 1994, the agencies, BLM, Alaska Fish and Game, EPA, Park Service, a couple others, we got together on a joint symposium to kind of talk about this problem. And actually there were 3 really good points that came out of here that helped us moving forward here when we started our dive into this in 2014. The first one was the importance of setting up a routine monitoring process that's consistent throughout the state for all the projects, and moving away from eyeballing, stream reclamation. And that's, even when I first started on with the BLM, it was generally, hey, look at that, you got a pilot channel, looks good, we're going with it, and trying to move away from that to a more rigorous process. Probably the most important recommendation that came out of the symposium was the vegetation components and how important it is to provide stability. And we'll talk more about that and how that plays into critical functions, especially here in the Arctic. And several recommendations that came out of this symposium, using science to help us create BMPs and better reclamation success. Creating a shift away from, using the off-the-cuff stuff to using actually science to inform us, developing training programs, and the creation of reclamation demonstration projects. And that's kind of a key one. There's been some growing pains with it. There's been some misunderstandings, but we've learned a lot through these demonstration projects. And I know the mining community has really benefited in this collaborative effort with these demonstration projects. So addressing a little bit more, diving into kind of looking beyond this qualitative approach, we looked around the state. Again, like I said, we started about this in about 2014 and started looking at what does the mined post reclamation mine site look like as compared to on mined, and trying to keep within that reference condition of these mined areas. And we have kind of core mining areas in the state where a lot of activity happens. And as you can see, most all of the areas that we studied that were mined and reclaimed are functioning essentially at risk or not functioning at all within its respective category. And that was kind of the keynote. That's kind of what we're seeing on the ground, the data supporting that. And we continued this kind of work looking into gathering more data and helping us understand what's really happening. And so the BLM kind of dove into this process of looking at what are the basics, like how can we work with the placer mining community and create something that can actually be implemented by the placer miners. So we worked with placer miners on demo projects and also in workshops. We supported the miners coming in, provided them tools and education to kind of understand some of these processes and principles. We did a lot of learning internally as well, and bringing our staff up to speed, not just all of the fisheries biologists and hydrologists, but we brought the mining staff and geologists in and made sure that geologists were getting a good level of understanding so they could speak to conditions on the site appropriately when they're visiting with the miner and when they're reviewing mine plans and reclamation plans. We understand that stream reclamation can be complex, it can be expensive. So a major goal of this project was to work with miners to set up foundations for reclamation success while keeping costs as low as possible so that it best fit their business models. So for the minimum that we came up with for what we need to aim for are four principles. The foundational principle being floodplain connectivity, providing stream bank vegetation, providing some type of bed form diversity, and then avoiding head cuts and mid-channel bars. So by working with reclamation plans to achieve those four categories, we found that we're able to achieve better reclamation success over the long run. And establishing these accounts for the dynamic nature of stream systems over the time. That's one of the key arguments and concerns we had is like understanding that streams move and adjust, and miners constantly their feedback is like, well, the problem is floods happen and streams move. And so we didn't want to create a condition where we can find the stream. We wanted to just create conditions where hopefully we set the best foot forward so that natural processes could be implemented faster. So geomorphic stability is what we're aiming for here. And then we're going to progress up from there. So here's another example, just kind of drive home some of these failures and things that we've learned from them. So here, this project was in reclamation phase. They completed a pilot channel. Looks like they have some type of floodplain connectivity. There's no vegetation, but also stream bed bedding and making sure that your pavement is appropriate is critical, because within 4 years, this downgraded and became an incised channel. You can see the vegetation came back, but because it became an incised channel, there was no ability to dissipate energy laterally. And so that energy went into a vertical system and essentially just eroded everything out. And that's a huge movement of material downstream that we wanted to avoid. Here's another example. This is kind of longer running, 15 years. You can see how these impacts, when you don't set the conditions right, what happens is in Alaska specifically, we see a lot of braided channels. The energy slows down so much that you just end up into these big riffles. You are unable to sustain vegetation, and that's in stark contrast to like the on-mined reaches above and below that are single thread with good vegetation. And so how do we get there without breaking the bank and making it function is the goal of this whole project. One thing that's unique to Alaska in our interior minings is off ice. This can be really damaging to reclamation. Within 1 day, actually off ice conditions completely unravel. They can completely unravel a reclamation project. Off ice is the product of during the cold winters when you're seeing 30, 40, 50 below zero, groundwater flow continues to push in. It overflows and essentially glaciates the valley bottom, and it can go from toe to toe of the valley, and it will act like a big dam. So when spring melt conditions come, that off ice is slower to melt than the surrounding snow. It'll create a big dam. It'll push it behind it. It'll flow around. It'll essentially demolish any reclamation you have in there. And it's common throughout interior Alaska to have off ice. So that was another thing that we wanted to work with miners on. That was a big question miners had, is like, how do we move past this? So the BLM, we decided to lean into this and really find a way to be a good steward of the land and supporting the mining industry. So we came up with some Alaska-specific support for stream design and reclamation. This is different than the tomes of information that have been previously done. This is much more photo intense with step-by-step pictures, and it's geared towards the audience, but also more than just providing them a piece of paper or a booklet. We also have an on-the-ground assistance process. So these are photo here on the right. You can see we have some BLM staff on the ground teaching the mine operators, that's actually an equipment operator for the mine, teaching them how to place vegetation mats at the correct elevation so that when they're done, you have the correct bench into your floodplain with living vegetation. And what we found is this is the key success here, is transplanting live vegetation, willows and other material. If we have a nearby stream that we can borrow from, excellent. Otherwise, there's other methodologies, but we've found great success and use this throughout the state. The transplant of live vegetation mats, miners find it easy. They just need to know what the elevation they need to shoot for, and they can put it in there, and essentially you have instantaneous vegetation cover along there. But additionally, what we've discovered is that placement of this vegetation, when it's large enough, you have to have a big enough piece of equipment, the bed's deep enough, that it actually helps to control or eliminate the effects of off ice, because even if the water backs up behind the off ice conditions, that vegetation helps to control those waters as they move around and into the floodplain. We've also put together some internal specific policy to help our staff move through this process. So to make sure that we're being consistent and equitable and reclamation plan review and how we're monitoring the reclamation plans. We've come up with some effectiveness monitoring guidance for the staff, but we've also put in this technical assistance process where we're actually, I've mentioned before, we're helping the miners, we're on the ground, but we wanted to look at it from the risk management perspective for the Bureau and how we could best facilitate industry without running into problems with, the BLM saying, hey, BLM said this was fine and it'll work, and then it unravels. We're doing the best we can with the science that we have. But due to the complexities of stream reclamation, technical assistance is an important tool. To date, the BLM has worked with 6 mine operations with technical assistance as a part of it. Overall, we've had about 10 operations that have implemented reclamation at this level. And then currently, we're also working on several mine plans that are in the works that'll be implemented in the 2025 and 2026 season that are also doing stream reclamation. And we're also going to be completing, hopefully, one of the largest stream reclamation plans in the state. They're going to be performing over 4,000 feet of high-level stream reclamation. So that's a pretty promising project. And that operator's been great to work with and eager to learn. So just kind of looking at what does this look like on the ground? What have we really learned? The Wade Creek here at the Race mine site, they wanted to get the stream out of the middle of their mining, and they wanted to move it once and they wanted to be done. This was one of the first projects that we did. What we've learned through our process is that a vertical step pool system with simple rock structures, so you essentially create a step pool system, is the most effective and easiest for the mine operators to implement. and easiest to demonstrate. So you just have a riffle that runs into a structure that just kind of has a pool downstream of it. And we teach them how to place the rocks to make sure that they're, they have a good toe rock and then your header rocks. And then placing the vegetation, and the key part of it is, grading and making sure that there's floodplain connectivity. But once that vegetation, all this vegetation you see here on the side, on this right-hand photo, that was all placed and has grown up and has good root depth, and it has been holding strong. Immediately to about 40 feet to the right of the vegetation, from where the folks are standing, is the Taylor Highway. So, I mean, it's really close to the highway. And then there's the active mining operation just off to the left. So it's forming as intended, and we're the miner is very excited about that. We have another project that we did. This one's a bit more complicated. It was in the Alaska Range, high elevation, extremely short growing season, and very, what vegetation is there, maybe gets about waist high. But this area here, previous mining back in the late 80s, essentially just left the entire thing as just one giant riffle. And it was unable to be able to get any kind of vegetation and move away from just being one solid, fast running stream. And so we worked with this miner to create the step pools that we talked about. Where there was limited vegetation, we used it in the most erosion prone areas. And then we worked with the miner to identify alternative methods. Riprap has a hard time holding on during flashy spring breakups, but we'll see how this one goes. But so far, it's been holding up. There's been some adjustments that have happened here, some infills with some pools and stuff, but lessons learned. And the operator's been really excited about working with this project and moving up. And this is the project actually that's doing a second phase that I mentioned before, where they're doing about 4,000 feet more up valley. This project, they did their operations in the mid 2000s, and then reclamation just could never take hold. The problem is that this is up in the Brooks Range, the foothills south facing side of the Brooks Range, and there is a really flashy small drainage here. They get really good rain events come through there, and this thing will just flow really fast for a really short period of time. And so we worked with them to use some great material that's on site. We have a lot of big rock and boulders to create some good footer structure. And we were able to work with them on creating a decent vertical control for step pools and dissipating that energy. Vegetation has been growing nicely out there as well and taking hold. This place suffered a lot from off ice. And since reclamation, off ice has not degraded the site down as it had been in the past. So that was a good product that supported some of our findings. This project, they mined this valley from toe to toe. Essentially, it was a complete mining project. They moved the stream several times, and again, using the same methodology of this kind of simple step structure with pools and riffles, they were able to achieve some great reclamation. They completed this reclamation in 2017. And so we were out there in 2024 taking a look at things, and it's coming along. And the placer miner is really happy with this one as well. And this had a lot of lessons learned on this project as well. And then lastly, this was kind of a joint effort. The miner did a lot of work, but the BLM also helped with some additional designs and construction through our crew that actually coordinates with DOT. So on the photo on the left under 2017 there, you can probably see a vehicle, on a white vehicle parked there. That's actually the Taylor Highway. And you can see that this the slope moves down into the stream, and then essentially the reclamation caused the stream to go right up against the toe of this hill where the vegetation is. And this kind of feeds into a bigger problem that we experience here in Alaska. Is this started exposing permafrost lenses at the toe of this hill, and was creating conditions that created a susceptible slope failure. due to permafrost melt, and we wanted to pull that away and provide for more insulation from that permafrost along that slope face. So we worked with the miner. They came back. They did a bunch of earthwork to kind of move things over, following the transplant methodology, which worked really well. And BLM came in. We worked with some engineers, and we created some additional structures that we wouldn't expect a placer miner to put in there. We helped turn the creek so that it wasn't going to impact the road downstream of here. And that process was great. It was a collaborative effort between the miner and the BLM. And we have several other projects actually here on Wade Creek that we've worked through. Been lessons learned, but overall has been a great success. So, going back again, kind of recapping, is we've learned the placement of live, thick vegetation mats right off the bat with good floodplain connectivity will create the greatest success right off the bat. And if we can get some bed form diversity through some creation of pools and riffles, with all those conditions, you're going to be able to avoid head cuts. You're going to be able to keep your single thread channel, and those will help progress it quickly to a condition where you're able to facilitate habitat if fish are present. And I do want to point out that almost all these projects that we've had, within 2 or 3 days, there are grayling returning to the streams and using them. And in fact, on this set right here, within about 12 hours after we'd finished construction, there was a gentleman on his RV had pulled over, walked down there, and was fishing grayling out of the hole right after reclamation. So that's a good use of the public lands. So that's a quick break into what we're doing up here. I'll open it up for questions. Hopefully audio work in our benefit here.
All right, questions?
Yeah. I guess just working with the mining companies to sequence continuous mining upstream to downstream would allow the use of the removal of side bank vegetation for restoration as a continuous effort. Not really questions as much as a comment.
This won't echo. How did you figure out the elevation for where to put the vegetation? What hydrology information did you use?
James, did you hear that one?
All right, can you guys hear me now? Sorry, we had a weird thing. Zoom was messing with us. All right, yeah, I did hear that question. We've figured out, so we did completed regional curves for each of our major mining districts by going out. We did essentially a whole series of cross-sectional longitudinal surveys on-mined reaches and then mined reaches. And we were able to come up with regional curves to help us figure out essentially what the general layout of the stream channel should be within the regional site conditions. And then prior to construction, we go out there and we actually walk through the process and we teach the placer miners how to do cross-sectional and longitudinal surveys to figure out where their ending elevations are. And from there, we, within that design manual that we have, which is our technical report 65, it walks through a process to essentially determine your bank height ratio based on your channel width.
Thank you. 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 Thank you.